All right, guys, so go ahead and open up your textbook to page 395. This is lesson 8-1, and we're talking about functions. So I'm gonna go over the vocab words here real quick. You can follow along in your book. Pause when you need to. So our new vocab words, we have an independent variable, dependent variable, vertical line test, and function notation. So I'm going to start off with the first two, an independent variable and dependent variable. So the number of pennants sold is called the independent variable because the values are chosen and do not depend upon the other variable. The total money earned is called the dependent variable because it depends on the input value. Okay, so what we are going to be doing here on example 1 is determining if a relation is a function. So I'm trying something different here. I have my little document. I'm using my phone as a document camera here with my whiteboard. So that's what's going on here. That's why it's looking a little bit different. So I'm gonna get that started and show you guys how to do this. So here is your guys' first example of a function. So we have on one side, so the left side here, we have the domain, and then the right side here, we have the range, okay? So in order for it to be called a function, it needs to have exactly one pair for its value. So for the first one, we have 2 and 1, 4 to 3, 5 to 4, 9 to 7. So this would be an example of a function. It would be considered not a function in a case like this. So if I have 2, 5, 9, and then for my range I have 1, 3, 4, 7. So for the number 2, the range is 1 and the range is 3. And then 5 matches with 4, 9 matches with 9. The reason this is not a function is because the 2, oh, my blue's not working. Because the 2 here has 2 different ranges. It has a range of 1 and 3. So this would be considered not a function. Not a function. Okay, so this is what we're going to do in example 1. So let's try it out. So with example 1 here, I wrote down the numbers. So at the bottom of page 395, we have pairs of numbers. We have 54 and 112. So those two are paired together. 56 and 130. We have 55 and 145. Those two are paired together. Then we have 54 and 123. And then you'll notice 56 pops up twice. We have 56 here and 56 here. So I do not need to write that 56 right there because 56 has 2 ranges. It has 2 ranges. So it has 2 different values. So that means that this is, I'm going to write it in red because red means bad, not a function. Not a function. Okay, and that's because it has 2 paired values. So what about letter B? What about letter B? So I'm going to write that one down real quick. Example 1, letter B. So we have, I'm going to write it how they have in an XY table. We have 4, we have 6, 7 and 10, 6 and 11, 3 and 8. Let me continue it down here. 5 and 4, and 2 and 9. So first off, we have to look at our X values. We need to look at the 4, the 7, 6, 3, 5, and 2. None of those numbers are duplicates, so that's good. Thumbs up. Thumbs up. There we go. We'll figure it out eventually. And then I need to look at my y's. Are there any duplicates? 6, 10, 11, 8, 4, 9. No duplicates. So we are good. This is a function. Get my green pen. Yay, function. Party, smiley face. Yeah. All right. So example 1 is a function. All right. Let's move on to the next page and try example 2. All right, guys. So example 2 is going over, it's using the what's called vertical line test. So I'm actually going to be using use this, let's see if this paper towel roll works. Oh yeah, that's gonna work. So what you would do when you're using a vertical line test, so with a vertical line test, you are looking at a graph to see for every x in the domain, you are going to look at the y-axis to see if there's any intersection points. So on page 396, I'm on example 2, it says, determine whether the graph above is a function. Explain your answer. So it says the graph is a function because the vertical line test shows that it passes through no more than one point on the graph for every x value, Okay. So when we're looking, I drew all my dashed lines here. So I drew dashed lines going all the way down for 1. I did it for 2, coming all the way down, for 3, and for 4. So going all the way across, we need to look at, so my first point, point number 1, is there any intersection? Why, yes, there is. Right here, we have 2 points intersect that are on the x-axis that intersect right there. We cannot have that. So what this would look like on an ordered pair, we would have 1 and 1. And so that would be this first point right here. And then the second one, we would have 1, 2. That's our x, that's our y, our x and our y. So we cannot have duplicates. The 1 right here and the 1 right here, those are duplicates. That means they, this is not a function. So this example is not a function. The only point that is on this graph that would be considered a function. So right here, those intersect. Right here, these intersect. But if you look at down at the end, the 4. So 4, 4 would be our only ordered pair that is actually considered a function. Everything else, it has an intersection point at some point. It has duplicate values there. All right. So example 2, let's try that out. Or example 3, yeah. Example 3, which is talking about functions. All right, guys, so this is an example of function notation. So function notation is a function that is written as an equation and also be in a form called function notation. So this is actually pretty fun stuff right here. So when it looks a little complicated, so our equation here is f of x equals 4x minus 7. All right, so for part A, we are going to do f of 5. So that means we are replacing our x with 5. So we are going to do 4 times 5 minus 7. See what we did there? I'm going to circle what we just replaced. So for our x right here and our x right here, we replace those x's with the 5s. That's all we're doing. That's all we're doing here. So now we can figure out what is f of 5. Well, now we just use PEMDAS from here. 4 times 5 is 20. 20 minus 7, that's 13. So f of 5 equals 13, right? You guys know how to do that. So f of 6, we would write f of negative 6, we would write 4 times -6 minus 7. So for f of -6, we have, first things first, 4 times -6 is -24 minus 7. 2 negatives, it's just going to make a bigger negative number. So -24 minus 7, that's going to be -31. -31. And if your question is, Mr. Doomer, can we use a calculator for this section? No, you cannot. No, you cannot. So for this, for functions, you cannot use, for this entire lesson, lesson 8-1, you cannot use a calculator. Okay, so that is example 3. So let's try the very last example, which is the real world example, example number 4. All right, so example 4, it's not too bad. We are using function notation to for this music example. It's not too bad. All we are doing here is, first off, for letter A, we need to write an equation, and then letter B, we need to plug in our values and solve for a unknown variable. So for letter A, I'm going to read the example. It says, Maria spent $22.50 downloading songs. So that's her total amount of money. She downloaded those songs to her digital music player from an online music store for 90 cents each. So 90 cents each, that's saying that that is going to be probably multiplied by an unknown number. So we need to write out a function. We need to write out our function. So we have total cost. So I'm going to write T for our total equals, and then I have that 90 cents. So I'm going to write 0.9. I could write 0.90, but I don't really need to write that 0 because I could write a bunch of zeros continuously forever. So I'm not going to do that. I'm just going to write 0.9. And since it is 90 cents per song, I would write 0.9 times S. So I'm just going to put a little S right there. All right, so T equals 0.9 times S. For our example, so that's part A. Part B, it wants to know how many songs was Maria able to download. So I need to write down the total amount of money here. So we have $22.50, or just 22.5, equals 0.9 times S. So I need to get S all by itself. S is my unknown variable. I'm going to write it in red there. So 22.5 equals 0.9 S. So I need to divide both sides by 0.9. This is going into what you guys did last year. Our divisor needs to be a whole number. So I'm going to multiply both the 2250 and the 0.9 times 10. That's going to give me 225 divided by 9. Okay, so 9 goes into 22 2 times. 2 times 9 is 18. 22 minus 18 is 4. Bring down my 5. 9 goes into 45 5 times. And I have no remainder, which means that Maria was able to download 25 songs. 25 songs. So for part A, it would be T equals 0.9 times S. And then our songs is 25 songs, is how many she was able to do. All right. So your lesson is not too bad here. So you're going to do page 397, numbers 1 through 20 all. And that's your homework for the day. All right. So I'm going to get this uploaded real quick so you guys can have something to go off of. So email me if you guys have any questions, or if you need any extra help, just come to the math meeting today. All right, that's all I got for you. Thanks, guys.